Hello, welcome to Boy K Productions. In this video, we are going to be talking about how to find the area under a curve. Now, I think all of you should be able to know how to find an area under a normal function, like a straight line, for example. Over like this plus 2, for example. Okay, as you can see, finding the area here isn't very hard. There's a triangle, so it's like, just half times base times height. As anyways, it gets tricky when we're talking about hello. Welcome to Boy K Productions, and in this video we're going to be talking about how to find the area under the curve. Now, I think all of you should be able to know how to find the area under a normal function like a straight line. That would be pretty easy, right? Just find it's a triangle, so it's half times base times height. It's not very difficult. But it gets more complicated when we are dealing with quadratic functions, such as this. Just this, I guess. Okay. So, how would you find the area here? Now, it's not a straight line, so we can't just find a triangle, but we use the same concept. Now, in a straight line, we try to use basic shapes to help us find the area. Maybe it's a trapezium, so you just find triangle and rectangles, or just triangles. In this case, we're also going to use basic shapes to help us find the area under the curve. Now, we have to first determine what basic shape do we want to use. Now, most people use rectangles, so I'll show you how to do it. So first we need to actually know what area we want to find. So let's just do this from here to and the origin. So the area under the curve should be this one, this here. So we have to find the area over here using that method. Now, so we plot the points for the boundaries. Now we're gonna put in this like line of code, basically. Oops. Upper. Okay, as you can see here, upper sum. Now this just basically creates the rectangles. Okay. Now function is f. Start value would be b. End value would be a. So this is like determines the boundaries of the area and like where the rectangle should be, number of rectangles, and we'll get to that later. So you just click this f. Now you have to type it like this. B. This case is a for us, and we can make this n. Enter. As you can see, it's a rectangle. Now, n, we didn't have an n, so it created a slider here. Slider basically kind of like we can change the number of something. So the minimum, make it 0, and the maximum, make it 100. Okay. Now, as you can see here, n here, if we increase the slider, it increases, and the maximum will be 100. As you might have noticed, the n corresponds to the number of rectangles there are over there. See, the more I increase, there are 20, whatever, 20, so it's about 20 rectangles. And this is 100 rectangles. And as you can also probably tell, that the US value here, or upper sum value, is slowly decreasing. Now, that is the area of the rectangles. Now, why is it decreasing? This is because upper sum the rectangles is actually the rectangles that is circumscribed of the line. Now what does that mean? It's basically just the rectangles that is slightly above the line or curve, because it's impossible to have a rectangle that is perfectly along the curve, because that would not make it a rectangle anymore. So to use perfect basic shapes, it would be a little bit outside of the line or above the curve, and that's okay. We're using this to approximate what is the area under the curve. Now, having only the circumscribed rectangles is not enough. We need the inscribed rectangles as well, which is basically the rectangles under the curve. What the heck? Cancel. Okay, click this one. Okay. Now we use lower sum. Okay, you can't really see. Okay, there you go. It's basically the same thing. F, start value, B, end value, A, and a number of rectangles would be N. Okay. Now, hold on here. How do you... Can you see that? As you can see the value of the lower sum there, and as we move the N slider, change the number of, oh, you can't really see that. Hold on. Settings, change the color. Pink, okay, pink. So you can see better. Okay, you can see that the pink one, the lower sum, is below the line. So that means it's inscribed rectangles. The rectangles that are below the line, and the upper sum, which is the conscribed rectangles, which is the rectangles above the line. Okay. So the lower sum area of the rectangles, the value is slowly increasing, while the upper sum value is slowly decreasing. Now, that means the difference is getting smaller and smaller and smaller the higher the value of N. And at some point, when the value of N is really large, the difference would be 0, and that makes upper sum, means that upper sum will be equal to lower sum. Now, what value would that be? That would be the area under the curve. That would actually be the area under the curve. Now, what I'm trying to tell you is, the whole video is basically how do you find that? How do you find that value that the upper sum and lower sum is leading into when the difference is 0? That would be the integral. As you can see, integral here, which is basically area under the curve based on start value x and value x, in this case b and a, of a function. So our function is f, and our start value is b, and our end value is a. Boom! Okay, hold on. That's our upper sum. That's our lower sum. And this is the area under the curve. This is what these two values are leading into when the number of rectangles is a lot. Well, that's pretty much it. Thank you for watching Boy Boy K Productions. Goodbye.